A forest guard in the Sundarbans Delta documented something in his incident report that his supervisors initially refused to file. A Bengal tiger had been tracking him for 40 minutes through dense mangrove. He knew it was there. The tiger knew he knew. At 3 separate points along the trail, the tiger had clear opportunity to attack from behind at distances where the outcome would not have been in question. It didn't. It did. At the third opportunity, the guard stopped walking, turned slowly, and faced the direction the tiger was moving through the vegetation. The tiger stopped. They held that position for nearly 2 minutes. Then the tiger turned and moved away through the undergrowth without completing the approach. It had been building for the better part of an hour. His supervisor's note in the margin of the rejected report asked the question that nobody in the office could answer. If the tiger wanted to attack, why did it wait long enough for him to turn around? Start with what a hesitation actually represents in a large predator's behavioral sequence. A hesitation is not indecision. That framing misreads what is happening at a biological level. A tiger that has selected a target and begun closing distance has already passed through the first several stages of a predatory sequence that evolution has refined across millions of years. Stopping within that sequence is not a malfunction. It is a recalculation. Something in the incoming sensory data has changed the cost-benefit output of the attack enough to pause the sequence while the predator's system updates its assessment. The hesitation is the gap between the original calculation and the revised one. And understanding what causes that revision requires. Understanding what big cats are actually calculating when they approach a human. Big cats are ambush predators built around a specific set of variables that have to align before an attack becomes worthwhile. The prey must be unaware of the predator's position. The approach angle must allow contact before the prey can generate sufficient escape velocity. The prey's physical capacity for resistance must fall within the range the predator can manage without serious injury risk. And the caloric return must justify the total energy and injury cost of the hunt. Humans disrupt every single one of these variables in ways that most prey animals do not. A deer does not turn and face a tiger. A sambar does not stop and hold eye contact for 2 minutes during an approach. A wild pig does not stand its ground on an open trail and refuse to display flight behavior. Humans do all of these things. Sometimes by training, sometimes by accident, sometimes simply because a person who has heard something in the vegetation behind them turns around to look before they think about whether turning around is the right choice. That turning is enough. Every time a human turns to face the direction of an approaching big cat, it breaks the first and most critical variable in the predatory sequence. The prey is now aware. The approach angle that was calculated for a target facing away is now pointing at a face, and a face means eyes. An eyes forward means predator status in the signal language that every big cat reads before it reads anything else. There is a physical calculation underneath the hesitation that matters as much as the sensory one. Big cats do not heal the way their prey. Animals do not heal. An injury sustained during a hunt does not resolve in a week and return the animal to full function. A damaged shoulder from a human who fought back unexpectedly. A torn muscle from a fall during a failed attack. A bite wound from a hand that found its way to the cat's face during the struggle. Any of these can begin a decline that ends in starvation months later. Prey animals that fight back unexpectedly are the most dangerous thing a big cat encounters. Not because they are strong enough to win, because they introduce injury risk into a calculation that the predator's survival depends on keeping conservative. Humans fight back in ways that are genuinely difficult for a big cat to model in advance. We do not have a predictable escape response. We do not run in the direction our body position suggests we will run. We pick things up. We use objects as extensions of our reach. We make sounds designed to startle rather than sounds produced by fear. A big cat that has hunted deer for its entire life has a very accurate predictive model of what a deer will do in the next 3 seconds of an attack. It has no equivalent model for a human. That missing model is what produces the hesitation. Not fear, not confusion. a gap in the predatory dataset that the cat system flags before committing to a sequence it cannot fully predict. The Sundarbans represent a specific case study that wildlife researchers return to repeatedly when this question comes up. Bengal tigers in the Sundarbans attack more humans per year than tigers anywhere else on Earth. The delta is their territory. Humans enter it to fish, collect honey, and harvest timber. The encounters are frequent enough that researchers have been able to build statistical pictures of when attacks happen and when they don't. The data produces a consistent pattern. Attacks happen overwhelmingly from behind and from ambush positions. Attacks on humans who have turned to face the tiger, even partially, are documented but represent a dramatically smaller proportion of the total. Attacks that were initiated, hesitated, and then abandoned almost always share one variable. The human demonstrated awareness before the sequence completed. Not combat ability. Not weapons. Not size. Awareness. The single variable that collapses the first and most critical requirement of every ambush predator's attack calculation, which brings everything back to that forest guard standing on the trail in the Sundarbans with a Bengal tiger 15 meters into the vegetation behind him. The 40 minutes of tracking represented a predator running a calculation across dozens of data points. The 3 hesitation points represented 3 moments where the incoming data produced a revised output that fell below the threshold required to commit. When the guard turned and faced the vegetation, the tiger's entire attack architecture became invalid simultaneously. The awareness variable failed. The approach angle failed. The resistance prediction model produced insufficient data to complete. The tiger that turned and walked away was not being merciful. It was not making a moral decision. It was running the same calculation it runs on every hunt and arriving at the same conclusion it always arrives at when the variables don't align. Not worth it. The hesitation before a big cat attacks a human is not a moment of uncertainty. It is a moment of arithmetic. And sometimes the maths doesn't work out in the cat's favor.